Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 31 we are going to discuss about the textile exercise question number 12.14. Now in 12.14 it is all about what we say how to get the product from what we have studied, all the preparation, chemical properties and all. From that we are going to prepare, that is conversions, or what we call it as how to prepare the given compound that we are going to see. Just a minute. Okay, you can see the question is given here. How will you prepare the following compound from benzene? So till now what you have studied, all that knowledge you have to use here and convert this. You can use any inorganic reagent, and organic reagent having not more than one carbon atom. So this is one very important condition what is given, not more than one carbon atom. So the first one is methyl benzoate. This is ether, what we say. Meta-nitrobenzoic acid, that already we have studied. Para-nitrobenzoic acid we have studied. Phenyl acetic acid, what we say, that also. And para-nitro-benzaldehyde. This all we have seen in chemical properties and preparation. Okay. So the first one, that is methyl benzoate, that we are going to see. Okay. You can see here, that is from benzene we are going to prepare methyl benzoate, what we say. Now in this case the first one what is done is halogenation, or we can also say bromination. In presence of FeBr3 you will get bromobenzene. Then this Grignard reagent, that is, this is your ARX with Mg. So what you will get, ARMgX. So this is your ARMgX, what we get, aryl group. So this is Grignard reagent what we have prepared. Then further treating it with, you remember, solid CO2 and then hydrolysis, what you will get, this group will be substituted, that is benzoic acid you get. What you get? Benzoic acid. Benzoic acid on esterification. Now in esterification we have seen cleavage of OH group, if you remember. Chemical properties, if you see cleavage of COH group, means from here OH will be removed and from here H. So that will get substituted here, remaining what is left out. So CO, then OCH3. So CO, then OCH3, what we say, get substituted and you will get methyl benzoate. Okay, so this was the simple reaction. Now the next one what is given, second one, that is meta-nitro benzoic acid from benzene. So benzene, again here what we say, halogenation is done, that is bromination. Again Grignard reagent what we say, you will get, this is Grignard reagent, ARMgX. Understood? Further the same thing and benzoic acid, and then this one what we call it as nitration is done. What is done? Nitration. So that NO2 group will get substituted at meta position. Understood? Then next one, from benzene we have to prepare what? Para-nitrobenzoic acid. So here it is very simple thing, what you see, anhydrous AlCl3 and CH3Cl, means what? Friedel-Crafts alkylation. What we have done? Friedel-Crafts alkylation. So you got what? Toluene, what we say, or methyl benzene, toluene. Right? Then this nitration is done. Nitration means concentrated HNO3, and this you will get two product. That is what you call ortho product and para product, but in this case this is a major, percentage is more in this case of pay. Then filtration technique, less boiling point. So what will happen, this will get separated first. So with separated by filtration, what we say, you will get what? Para product, that is a major product, which on oxidation in alkaline KMNO4, oxidation you do in presence of dilute HCl, second you will get what? Now this group whole, that is get substituted by the C double H, that is what we call it as benzoic para-nitrobenzoic acid. What is the word? Para-nitrobenzoic acid is formed, right? Then same reaction what is the next one what is given here, that is to prepare phenyl acetic acid. Now phenyl acetic acid, again same, Friedel-Crafts alkylation. Clear? You get what? Toluene or a methyl benzene, bromine and HV. This is your bromination. You will get what? Bromo, what you call it as group gets substituted instead of this hydrogen. Then alcoholic KCN. what we say, and heating the mixture, this Br group will be substituted by Cn group further on hydrolysis. Clear? Like this, hydrolysis, acidification, what we say, you will get what this C, and that is N. Cn means C triple bond N it is, right? So here C double bond O and OH, like this. So bond will be 3 only, but one O and OH, that is according to mechanism, this group is substituted here. Understood? So you get phenyl acetic acid. Then the last one, from benzene you have to prepare what? Para-nitro benzaldehyde, not benzoic acid. This is aldehyde. What we have seen here was benzoic acid. Understood? So here in this case, if you see, okay, so here if you see in this case, benzene is there. Again what I said here, Friedel-Crafts alkylation, you will get toluene or methyl benzene. This is nitration, and heating you will get two products, para and ortho, in which this is the major product. For again separation by filtration, you will get para product which on oxidation, or if you remember this one we have chromyl chloride, if you remember that topic, clear, that we do in presence of H3O plus, you will get para nitro benzene. Now this is an important conversion what you have to remember from benzene. Understood? Now question number 15 we are going to see. Okay, now in this question if you see, how will you bring about the following conversion in not more than 2 steps? This is also a condition what is given, not more than 2 steps. So you have to be very careful in this case. Here a conversion it is. So these are the questions which are asked for 4 marks, what we say, right? This one also for 4 marks it is asked. Okay, so this one we are going to discuss. This is an important question what you have to remember. No need to learn by heart. Use your what you call knowledge of preparation and chemical properties. It will be easy. See, from ketone you have to convert it to alkene, what we say. Understood? Now alkene means aldol and all what we have seen. Now based on that only we are going to do this first one what we say. Just a minute. Okay. Now in this case propanol means ketone NaBH4 and Ca3OH, sodium borohydrate, and in presence means mixed with alcohol, reduction is carried out. Reduction means what will happen, there will be an addition of hydrogen. What is the word? Addition of hydrogen. So you can see here this according to mechanism, oxygen is more electronegative. It will take an electron pair and that will form CO minus with electron charge, what we say, and from here hydrogen we get, that gets substituted at this O, what we say, right? So you got this alcohol, that is what is it, propane 2-OL, propanol. Again what you call dehydrating. Dehydrating means what? Removal of water molecule. Understood? CO concentrated H2SO4 is used as a dehydrating agent. Means what we are doing here, dehydration, removal of water at this temperature. What will happen, from here OH will be removed and from here one H will be, means water molecule is removed and you get here propene, what we call. Then next one, benzoic acid. From benzoic acid we have to prepare benzaldehyde, the simple thionyl chloride, right? Most preferred method because these both are gas, so separation is easy. So from thionyl chloride you get this ArCOCl, if you remember, acetyl chloride, acid chloride, what we say here. Then further H2 hydrogenation in presence of palladium as a catalyst and BaSO4 plus S or phenolene. This you can use here. What you will get directly, this one will get substituted with this H, right? This way you can remember, actually mechanism is different, what we say. Then the next one, ethanol in presence of copper catalyst, what you will get, aldehyde, it will get converted into. Then dilute NaOH means aldol condensation, right? So in that you will take 2 molecules of this, means what, CH3CHO plus CH3CHO, 2 molecules you will take, and then this reaction, dilute NaOH. So what will happen, from here this is alpha and this is beta, right? So from beta you have to add oxygen here, hydrogen here, and alpha you have to remove hydrogen from this one. So this will be CH2, you can see here, and from CH you have to add hydrogen to also OH. So this is your aldol product. Which product? Aldol. But which aldol? So it is self-aldol product. Understood? So 3-hydroxybutanol. Okay, so this one is one what you have studied already in aldol condensation, you can remember. Then from benzene you have to prepare meta-nitro acetophenone. So this one we have seen This is what acid anhydride, what we seen, if you remember, or acylation. Friedel-Crafts acylation. This is acetyl group, what we say. What you will get? Acetophenone, what we say, no, like that, what we say. Then this is nitration, what we say. Nitration. See, if you don't know these few names, no, I will write it down here. And this is benzoyl chloride. Just a minute. Benzoyl chloride. Clear? This is your acetophenone. Understood what we said? Nitration you do, you will get nitro group substituted meta position, so meta nitro acetophenone. Then what we say, the next one is benzaldehyde. So this is your benzaldehyde K2Cr2, and that is acidic K2Cr2O7. The word is what? Acidic, H plus means. So you can see here benzoic acid. Clear? Then what is given? CaCO3 you use. This will remove water molecule from benzoic acid. If you don't remember, this C6H5C double H, now I will write here C6H5C double bond O and OH, same way C6H5C double bond O and OH. So this is used as a dehydrating agent. This will remove water molecule or moisture, what is it? So here water molecule is removed, so you will get C6H5. This is C6H5CO twice and this O from here. Okay, so this is the one. Then distillation you do, you will get what? Benzophenone you get. What you get? Benzophenone. Understood? Then, or another is also given. This is same acidic K2Cr2O7, benzoic acid, thionyl chloride you use, you will get this benzoyl chloride, what we say. Understood? Acetophenone, sorry. And then C6 benzene anhydrous AlCl3. This thing will be substituted by C6H5, what we say. Right? Cl will be substituted by C6H5. Then you can see bromobenzene. This is your Grignard reagent, that is ArMgX, dry ether. Then further with aldehyde, and then with this you will get 1-phenyl ethanol. 1-phenyl ethanol. 1-phenyl means 1 and 2. What we say? From that the name 1-phenyl ethanol. Phenyl means C6H5 group, benzene ring. What we say? Then the next one what we say is aldehyde, benzaldehyde, again with what? Ethanol. Now this is cross aldol. Why? Because both products are different, what we say, right? So you will get what? In this case what I said, this is alpha, and here what you have to, you take it this as beta, right? Now this is direct cross aldol condensation. Condensation means removal of water. So how to remember? From here you remove H2, that is from alpha position, right? And from beta position you remove oxygen. So what is remaining? CH. Here there CH, then double bond, and then at alpha, the alpha and beta you have to join. This is alpha, this is beta, right? So from here CH you can see 2 hydrogen is removed. CH3 was there, now only CH, CHO. So this is your benzaldehyde. Then hydrogenation in presence of nickel catalyst. What will happen? This water, this H will get substituted here. So here if you see H, no, here one more H, and here only one H was there, another H will be here, and remaining is CH2OH. Means what? C double bond O and H was there, no? See, oxygen will take the electron pair. So what will happen in this case? Here H will get substituted from this hydrogenation, catalytic hydrogenation. So 2 to 3 phenyl. 3 phenyl means why? This is 1, this is 2, and this is 3. So 3 phenyl propane 1-ol, like this, what we say, right? Then next, benzaldehyde, and what is given there? NaCN and HCl. pH you have to maintain 9 to 10, means what? Alkaline pH, what we say. What will happen? This part will, oxygen will get substituted with Cn, and here there will be OH. The reason is what? Because C double bond O and H, what we write, no? As O is more electronegative, so here it will form CO minus, nucleophilic center, and H. So that H will be replaced here, so that is your OH, what we say, right? And this O will be replaced, what we call it, sorry, not O, this will be replaced by Cn group, what we say, remaining, because here first double bond was there, now here again one substitution can be done, so that's why this Cn group is substituted on this carbon, carbonyl carbon. Then hydrolysis you do. What will happen in this case? Hydrolysis, this one what we call change into this part. Understood? Because C, what I said is triple bond N like this. Then what happens? C double bond O and OH. So if you see this three-way only it is being bonded, so valency is being satisfied. Okay, mechanism is there, but we are not going to discuss that. This is alpha hydroxy phenyl acetic acid. This is the last chemical property there what we have discussed this. Okay, then benzoic acid, what we say? Benzoic acid, this is nitration, what we say? Nitration is done, so nitro group substituted at meta position, thionyl chloride you use, so what will happen? Cl group you will get here, and then reduction. This is what actually sodium borohydride right now. Reduction is carried out, so O you can see here, this one, H and OH, and then meta nitro benzyl alcohol, what is being the product what you get. Understood this part? So here this was all about what you have, then reduction, and then with the acid, what we say, H plus H2 also you can write if you want like this. Okay, acidification, you will get meta nitro benzyl alcohol. Understood this part? So this was all about what you call it as we discussed 14 and 15. Okay, now the next one. Okay, now we are going to discuss the next question, that is 12.16. These are the questions 1-1. Can we ask for 3 marks? That is acetylation, Cannizzaro reaction, cross Aldol condensation, decarboxylation. These all things we are going to discuss next. Okay, just a minute. Okay, now the 16th question what we are discussing about. First one we are going to discuss about acetylation, the replacement of active hydrogen of alcohol, means this one, right? Phenol or amines, that is phenol amines means what we call it as NH2. From that hydrogen we are going to replace phenol when we say on benzene ring OH group, so that H, this will be replaced, and from alcohol from OH group H, this replacement of this with acetyl groups. Now when we say acetyl group means what? RCO group. Which group? RCO. So like this what we say, or you can also write it as RC double bond ON like this group. We are replacing hydrogen with RCO group to form corresponding ester. To form what? Ester or amides. Amides, ester means I think you know, RCOOR, what we say. Amides when we say means CONH2, right, is called acetylation. It is carried out by using acid chloride, means RCOCl. These are acid chloride, or anhydride, that is RCO twice O. These are anhydride in presence of a base, base such as pyridine. Pyridine, when we say pyridine structure is like this, nitrogen is there. In this case, here is a heteroatom. This is pyridine. It's a strong base. Strong base. What? Pyridine. Right? So pyridine, dimethyl aniline. Now dimethyl aniline. Aniline means on benzene ring. What we call it as? Which group? NH2 group is aniline, what we say, and dimethyl, what we say. So here what we say, here and here, whatever. Right? Now for example, see, acetyl chloride when treated with ethyl alcohol in presence of pyridine. Pyridine is used as a base, right? What will happen? This H will be replaced by Ca3CO group, means instead of this H, what will come now here? Ca3CO, means here, this one. Right, so this what we have written here, no, CH3, CH2 and O of alcohol. From that what is removed? H is removed, and this CO, that is CO group, that is C double bond O and CH3. This is being replaced, what we say. Understood? They have written little bit here, but I have written like this. So this being replaced by this group. What is replaced? Hydrogen of alcohol is replaced, is called what we call it as acetylation in presence of strong base pyridine. Okay, now the next one. In the first, there only acetylation, there was what we call, we saw acetyl chloride as acid chloride. This is acid anhydride. So that Ca3CO group will be substituted with the H, what is a Ca3CO group. Instead of H, it is being substituted, and another acetic acid will be formed from this. Okay, understood? Now then Cannizzaro, what we say. Cannizzaro we know, aldehyde which do not contain any alpha hydrogen atom, that is benzaldehyde or formaldehyde, undergoes self-oxidation. What is the word? Self-oxidation and reduction reaction, what we say, on treatment with concentrated solution of caustic alkali, that is concentrated NaOH. right? It can also be written as 50% NaOH. In this reaction, one molecule is oxidized and the other, while the another molecule is reduced, means disproportionation reaction what we see. So here formaldehyde, when you see in this case formaldehyde, this one molecule will change into methyl alcohol and another molecule will change into what? This one. Further on acidification will give you an acid, HCOOH it will change. Okay, so in this case you will see there is an addition. Here only one oxygen is there, here two. So this one is oxidation product, right? Here hydrogen is 2, but here hydrogen is total, what we say it as 3 and 1 4. So here hydrogen is added, so this is the reduction product what we say, right? So one is oxidized, one molecule is oxidized and one molecule is reduced what we say. Understood? So that is Canizaro. In this case also benzaldehyde, what is given? This is what? Benzaldehyde. Both one. This is also benzaldehyde. Now 50% NaOH, concentrated alkali. One molecule will be reduced and another molecule will be oxidized. Understood? That is Canizaro. Then comes cross aldol. Now till now we have studied about cross aldol in your textbook. Both were in which alpha hydrogen were there, but in this case there is no alpha hydrogen. But in this case there is alpha hydrogen is present. So here this is little bit different. So this you can write it down as an example. But here you will get only aldol product in this case. Understood? Here also you are getting which product? This is also aldol product. Aldol, not ketol product, because ketone is used. And in this case what you say, you will get here aldol ketol product. Understood this part? Because when ketones are used, ketone are used, you will get ketol product, and when aldehydes are used, you will get what? Aldol. But here remember, here also in this case there is no alpha hydrogen. Okay, here also in this case there is alpha hydrogen, so we will not tell this. Now see, in this case the reaction stop at this position only, because there will be no formation of enolate ion further. That's why it will stop here. You have to see the mechanism in aldol reaction what is given there in your textbook. Now the condensation of two different molecules of aldehyde ketone is called cross aldol condensation. Remember, different molecule of aldehyde or ketone means either you take both aldehyde, you take one ketone and one aldehyde, or one aldehyde and one ketone, right? Any. It is useful in synthesis, what I call synthetic reaction, only if one aldehyde does not contain alpha hydrogen atom. That is formaldehyde and benzaldehyde. Understood this part? Now in this case acetaldehyde and formaldehyde, dilute NaOH you take. What will happen in this case? I already explained. Whichever you take alpha, from there you remove what you have to add hydrogen, or you remove oxygen, what we say hydrogen, that I have explained you in this case. Okay, so here formaldehyde is there and here what is there? Acetal. There is no alpha hydrogen, so this will take it as beta only, right? So here you can remove this hydrogen, this one, and here you can see here what is remaining, CH3. Here addition will be there at this position. Here one hydrogen and here H will be added. So you can see. Now if you don't understand this, you write it separately as like this, what we say, CH3 CHO plus HCHO, like this. Understood? So it will be easy to understand, and our technique you can use for here. Here it will be dilute NaOH. A catalyst used as a NaOH is a base which is used as a catalyst. Okay, so this is beta hydroxy product what you get, that we call it as what? Aldate. Now in this case you remove hydrogen from this, you take it this only as alpha, and you take in this case as a beta, what we say. For this one you take it alpha and this one you take it as beta. Understood? So here you have to add here and you have to remove here, like this you can do. Okay, but in this case you can go through this if you want. I'll explain it in another videos if you want. Okay, then acetone and formaldehyde, what is given? You will get 4-hydroxy butane 2-on. Then benzaldehyde and acetone, you will get what? 4-hydroxy 4-phenyl butane 2-on. Okay, now next last one is decarboxylation. Decarboxylation means removal of carbon dioxide. The process of removal of molecule of CO2, this one, from carboxylic acid is called decarboxylation. It is usually carried out by heating a mixture of a carboxylic acid or a sodium salt with soda lime. Now when we talk about in this case, what will happen in this case? COO Na and this one here. So Na2 and CO3 here. This is the box what I have drawn. Will get removed and you will get what? Ethane you will get. Same thing here also you can see this part here and here, from here this part what we say like this is removed, means Na2CO3 is removed. What is this H? This is C6H5COO Na, right? So here what will happen in this case? This C6H5 this H will get substituted, so it will become C6H6 over, and this Na2CO3 is removed. So this is decarboxylation reaction. You can write down, can be asked for 3 marks also. Okay, this one if you didn't understood, I will explain in the next video what we say. Okay, this only this part, cross Aldol condensation of one which does not contain alpha hydrogen and one which contain alpha hydrogen. Okay, that I will be explaining in the next video. Understood? So we will stop here. In next video we will be continuing with the question number 17 of your textual question, that is complete each synthesis by giving missing starting material, reagent or product. Okay, till then, thank you very much.